Our planet Earth is ancient. It has a history stretching back billions of years. Long before humans walked this world, it was a place of immense change. Continents drifted, oceans formed and reformed, and mountains rose and fell. Life, in myriad forms, has called this planet home for almost its entire existence. Imagine looking back through this deep time. You would see landscapes and creatures that seem alien to us now. The air, the oceans, the very continents were different. This vast expanse of time before our arrival is a story written in the rocks and fossils of our world, a story of constant transformation and evolution, setting the stage for our own eventual appearance. Life's journey began humbly, perhaps in warm, shallow waters or near volcanic vents deep in the ocean. The first life forms were tiny, simple cells. For billions of years, these microscopic organisms were the dominant life on Earth. They slowly changed the planet. Some learned to harness the sun's energy through photosynthesis. This process released oxygen into the atmosphere. This was a pivotal moment. It transformed our world, paving the way for more complex life to emerge. The slow, patient march of evolution was underway, a process of trial and error on a planetary scale, leading to ever greater diversity. The Earth itself was a dynamic stage for this unfolding drama of life. The continents, great land masses, were not fixed. They moved across the globe, crashing into each other, pulling apart. This continental drift altered ocean currents and weather patterns. Climates shifted dramatically from scorching heat to icy cold. Life had to adapt to these constant changes. Some species thrived, diversifying and spreading. Others couldn't keep up and vanished forever, becoming extinct. This constant interplay between a changing planet and evolving life is a central theme in Earth's long story, a cosmic ballet performed over eons. We humans are very recent arrivals on this ancient stage. If you condensed Earth's entire history into a single day, human existence would be just a few seconds at the very end. We appeared in the last fleeting moments of this immense timeline. Understanding the worlds that came before us is vital. It helps us to grasp our own origins. It shows us how life can change and adapt. It gives us a profound sense of our connection to all life that has ever existed on this pale blue dot. Our story is deeply intertwined with the story of Earth, a story that began long before we ever did. The story of our own specific lineage, the hominins, begins much more recently. It unfolds primarily in Africa, the cradle of humankind. Millions of years ago, the great apes like chimpanzees and gorillas were already established. We share a common ancestor with them, but at some point a new branch began to sprout on the primate family tree. This was the branch that would eventually lead to us. These early ancestors were not yet human, not as we understand the term. They were transitional forms, creatures taking the first tentative steps on a new evolutionary path, venturing out of dense forests and into more open lands. One of the earliest known hominins is Ardipithecus. Fossils of, nicknamed Ardi, were discovered in Ethiopia. These individuals lived around 4.4 million years ago. Ardi's skeleton reveals a fascinating mix of traits. She could walk upright on two legs, a key feature of hominins. However, her feet still had a grasping big toe. This suggests she was also comfortable climbing trees. Her brain was small, similar in size to a modern chimpanzee's. Ardipithecus offers us a glimpse of what a very early ancestor, close to the split from other apes, might have looked like, a creature adapting to life both in the trees and on the ground. Following Ardipithecus, we encounter the genus Australopithecus. This group of hominins lived in Africa between roughly 4 million and 2 million years ago. Perhaps the most famous Australopithecus fossil is Lucy. She was a member of the species. Lucy lived about 3.2 million years ago. Her skeleton shows even clearer adaptations for walking upright. Her feet were more human-like, lacking the grasping toe of Ardi. Though they walked on two legs, Australopithecines like Lucy still had relatively small brains compared to modern humans. They also had long arms, suggesting they still spent some time in trees, perhaps for safety or food. These early hominins, Ardipithecus and Australopithecus, were not human. They didn't make complex tools or control fire. but they represent crucial steps on the journey towards humanity. They demonstrate the gradual nature of evolution, small changes accumulating over vast stretches of time. Their fossils are precious whispers from our distant past. They tell us about the challenges our ancestors faced. They show us how our unique human characteristics like bipedalism began to emerge. They are foundational figures in the epic story of human evolution, the ancient roots of our family tree. A significant new chapter in our story opened with the emergence of the genus. This is the group to which we belong. The first members of our genus appeared in Africa around 2.5 million years ago. This was a time of considerable environmental change. The climate was becoming cooler and drier, forests were shrinking, and savannas were expanding. These changes likely played a role in the evolution of. A key characteristic of this new genus was a noticeable increase in brain size compared to the earlier Australopithecines. This larger brain would pave the way for new behaviors and abilities. One of the earliest members of our genus was, meaning handyman. This name was given because of the discovery of simple stone tools alongside their fossils. These tools, though basic, represented a major technological breakthrough. Could use these sharp flakes of stone to butcher animals. They could cut through tough hides and scrape meat from bones. This gave them access to new, energy-rich food sources. Tool use also suggests a developing intelligence, the ability to plan, to visualize a tool within a piece of rock, and the skill to create it. This marked a new level of cognitive ability. Later, around 2 million years ago, a new species have appeared, the upright man. These hominins were different. They were taller than, with body proportions much more similar to modern humans. Their brains were significantly larger too, was a highly successful species. They developed more sophisticated stone tools like the hand axe. Perhaps most importantly, evidence suggests they were the first hominins to control fire. Fire provided warmth, protection from predators, and a way to cook food. Cooked food is easier to digest and provides more energy. This was a revolutionary innovation. Was also the first hominin species to venture out of Africa. Their fossils have been found across Asia and parts of Europe. This expansion across continents was a remarkable achievement. It demonstrates their adaptability and resilience. They thrived in diverse environments for an incredibly long time, over 1 million years. They were true pioneers, exploring new lands and facing unknown challenges. The story of is one of increasing intelligence, technological innovation, and the beginning of humanity's global journey. They laid much of the groundwork for what came after. Imagine a world where we were not the only kind of human. For a significant portion of our history, that was the reality. One of our closest extinct relatives was the Neanderthals. They were a distinct species, or perhaps a subspecies of human. They were powerfully built, with stocky bodies and short limbs. These features were likely adaptations to the cold, harsh climates of Ice Age Europe and Asia, where they primarily lived. They were not the brutish cavemen of popular caricature. They were intelligent and resourceful. Neanderthals inhabited their territories for a very long time. They appeared on the scene around 400,000 years ago and persisted until about 40,000 years ago. During this vast stretch of time, they faced dramatic climate shifts, including multiple glacial periods. They were skilled hunters, capable of taking down large game like mammoths, woolly rhinoceroses, and bison. They developed sophisticated stone tools known as Mousterian tools. These were more refined than the tools of earlier hominins. There is also evidence that Neanderthals buried their dead, sometimes with grave goods. This suggests a capacity for symbolic thought and perhaps even spiritual beliefs. The brains of Neanderthals were, on average, slightly larger than the brains of modern humans. This doesn't necessarily mean they were smarter in every way, as brain organization also matters, but it certainly indicates a high level of cognitive ability. They lived in small family groups. They likely used language to communicate, though the exact nature of their speech is debated. They cared for their sick and injured. Fossil evidence shows individuals who survived severe injuries which would have required help from others. Their world was a challenging one, demanding cooperation and ingenuity. So what happened to the Neanderthals? Why did they disappear? This is one of the great mysteries in human evolution. Several factors may have played a role. Climate change could have put pressure on their traditional food sources. Competition with incoming groups might have been a factor. Perhaps modern humans had slightly more advanced technology or social structures. It's also possible that Neanderthals were absorbed into the larger population through interbreeding. Whatever the precise reasons, their story is a poignant reminder that human evolution was not a simple linear progression, but a branching tree with many fascinating side paths. Section 5. Shadows in the Caves. The Denisovans. Beyond the Neanderthals, another group of ancient humans shared the planet with our ancestors. These are the Denisovans. They are a much more recent discovery, and our knowledge of them is still emerging. Their existence was first revealed not by a complete skeleton, but by a tiny fragment of a finger bone. This bone, along with a few teeth, was found in Denisova Cave in the Altai Mountains of Siberia. Scientists were able to extract ancient DNA from this finger bone. The DNA told an astonishing story. It belonged to a population distinct from both Neanderthals and modern humans. The genetic evidence indicates that Denisovans were a sister group to Neanderthals. They shared a common ancestor with Neanderthals, who in turn shared an earlier common ancestor with us. While Neanderthals were primarily found in Europe and Western Asia, Denisovans seem to have been more widespread across Eastern Asia. Their genetic signature has been found in modern human populations in Southeast Asia, Melanesia, and Australia. This suggests that Denisovans occupied a vast and diverse range of environments, possibly including high-altitude regions like the Tibetan Plateau. Our understanding of Denisovan physical appearance and behavior is limited due to the scarcity of fossils. We have a few teeth, a piece of a skull, and the finger bone. These fragments hint at robust individuals. The tools found in Denisova Cave in layers associated with Denisovans include sophisticated stone tools and ornaments, such as pendants made from animal teeth. This suggests they possessed advanced cognitive abilities and engaged in symbolic behavior, much like Neanderthals and earlier. They were clearly a capable and intelligent group of hominins. Like the Neanderthals, the Denisovans eventually disappeared as a distinct group. The reasons for their decline are also not fully understood. It's likely a complex interplay of factors, perhaps including climate change and interactions with other human groups. The discovery of Denisovans has added another layer of complexity to the human story. It shows that the world of our recent ancestors was populated by a greater diversity of human-like beings than we previously imagined. They are a shadowy but significant part of our shared human heritage, their legacy living on in the DNA of some present-day people. Section 6. A Shared World. Encounters and Legacies. Our species originated in Africa. The current evidence suggests this happened around 300,000 years ago. For many tens of thousands of years, our ancestors lived and evolved solely on the African continent. Then, in a series of migrations, groups have begun to expand out of Africa. They moved into the Middle East, then spread across Asia, Europe, and eventually to Australia and the Americas. As they ventured into these new lands, they were not alone. Other human species like the Neanderthals and Denisovans already inhabited these regions. Inevitably, these different groups of humans met. The encounters between Neanderthals and Denisovans were not always just about competition. Genetic evidence has revealed a fascinating aspect of these interactions. They interbred. Yes, these different human groups mixed their genes. Traces of Neanderthal DNA are found in the genomes of most non-African people today, typically making up about 1 to 4% of their DNA. Similarly, Denisovan DNA is found in some modern human populations, particularly in Melanesia and parts of Southeast Asia, where it can reach up to 6% in some individuals. This tells us that these ancient encounters sometimes led to offspring who survived and passed on their mixed heritage. This genetic inheritance from Neanderthals and Denisovans may have had important consequences for our ancestors. As moved into new environments in Europe and Asia, they encountered new diseases, different climates, and unfamiliar food sources. The genes they acquired from Neanderthals and Denisovans, who had already lived in these regions for hundreds of thousands of years, might have provided some advantages. For example, some Neanderthal genes found in modern humans are related to the immune system, skin pigmentation, and metabolism. These could have helped our ancestors adapt more quickly to these new challenges. The discovery of this ancient interbreeding has profoundly changed our understanding of human evolution. It means that the story of modern humans is not one of simple replacement of other hominin groups. Instead, it's a more complex and interconnected narrative. We carry within us a small genetic legacy from these extinct cousins. It highlights the shared ancestry and the fluid boundaries that sometimes existed between different human populations in the past. The human family tree is more like a tangled web, with branches occasionally rejoining. This intermingling is a testament to our deep shared past on this planet. Section 7, a realm of giants, dinosaurs and ancient beasts. Long before any hominin foot ever touched the Earth, our planet was home to an astonishing array of life. For an immense period known as the Mesozoic era, which lasted from about 252 to 66 million years ago, dinosaurs were the dominant land animals. This was the age of reptiles. Imagine a world ruled by these incredible creatures, towering sauropods like Brachiosaurus with necks reaching to the treetops, fearsome predators like Tyrannosaurus rex with its massive jaws and tiny arms, armored dinosaurs like Triceratops with its 3 horns and bony frill. The diversity and scale of dinosaur life were truly mind-boggling. The world of the dinosaurs was very different from our own. The continents were arranged differently. The climate was generally warmer and more humid. Pterosaurs, flying reptiles, soared through the skies. Some were as small as sparrows. Others had wingspans like small airplanes. The oceans teemed with giant marine reptiles like plesiosaurs and ichthyosaurs. For over 150 million years, dinosaurs and their reptilian relatives thrived and diversified, filling almost every ecological niche. Their reign was one of the longest and most successful in the history of complex life on Earth. Human history, by comparison, is a mere blink of an eye. The age of dinosaurs came to a dramatic end about 66 million years ago. The cause was a cataclysmic event. A massive asteroid about 10 kilometers wide slammed into the Earth near what is now the Yucatan Peninsula in Mexico. The impact unleashed unimaginable devastation. It triggered widespread tsunamis, earthquakes, and volcanic eruptions. A vast cloud of dust and debris was thrown into the atmosphere, blocking out sunlight for months or even years. This led to a global cooling and the collapse of food chains. The dinosaurs, along with many other species, could not survive this sudden and catastrophic environmental change. After the extinction of the non-avian dinosaurs, new opportunities opened up for other groups of animals. Mammals, which had lived in the shadow of the dinosaurs for millions of years, began to diversify rapidly. During the Cenozoic era, the age of mammals, which followed the Mesozoic, many familiar and some very unfamiliar mammals evolved. There were giant sloths, woolly mammoths, saber-toothed cats, and enormous flightless birds. The Earth's ecosystems slowly recovered and reshaped themselves. This constant cycle of extinction and diversification is a fundamental part of life's story on our planet, a testament to its resilience and endless creativity. Section 8. Stories in Stone. The Fossil Record's Testimony. How do we know about these ancient worlds and the creatures that inhabited them? How can we reconstruct the lives of dinosaurs or our own distant hominin ancestors? The primary source of our knowledge comes from fossils. Fossils are the preserved remains or traces of ancient life. They are like messages from the past, written in the language of stone. These remnants can take many forms. They can be mineralized bones, teeth or shells. They can be impressions of skin or feathers. Even footprints, burrows or fossilized droppings can tell us a great deal about ancient organisms and their behaviors. Finding fossils is a painstaking process. Paleontologists, the scientists who study fossils, search in rocks of the right age and type. When a fossil is discovered, it must be carefully excavated, often from hard rock. It's like a giant three-dimensional jigsaw puzzle. Each fossil is a precious clue. A single bone can tell us about the size and shape of an animal. Teeth can reveal its diet. The structure of limb bones can indicate how it moved. By studying many fossils, scientists can piece together a more complete picture of ancient life forms and the ecosystems they inhabited. The layers of rock in which fossils are found also provide crucial information. Sedimentary rocks like sandstone, shale, and limestone are formed from layers of mud, sand, and other particles that accumulate over time. Generally, older layers are found beneath younger layers. This principle, called superposition, helps scientists determine the relative ages of fossils. By combining this with radiometric dating techniques, which measure the decay of radioactive isotopes in rocks, scientists can assign absolute ages to fossils, often with remarkable precision. This allows us to build a timeline of life's history on Earth. The fossil record is not perfect, it's an incomplete story. Not every organism that ever lived became a fossil. The conditions for fossilization are rare. Soft-bodied creatures are less likely to be preserved than those with hard shells or bones. Erosion and geological activity can destroy fossils. Despite these limitations, the fossil record we do have is a treasure trove of information. It provides compelling evidence for evolution. It shows how life forms have changed over time, how new species have arisen, and how others have gone extinct. It is a direct window into the deep past of our planet. Section 9. Echoes of the Past, Lessons for the Future. Why should we care about life that existed millions or even billions of years before us? Studying this deep past is far more than just an academic exercise. It is fundamental to understanding our own place in the universe. It provides context for our existence. When we see the immense timescales of Earth's history and the incredible diversity of life that has come and gone, it gives us a sense of perspective. We realize that humanity is but one small part of a much grander, ongoing story of life on this planet. This cosmic perspective can be both humbling and inspiring. The story of past life offers profound lessons about adaptation and change. We see countless examples of how organisms have evolved in response to shifting environments. Species have developed new traits, colonized new habitats, and faced new challenges. We also see that extinction is a natural part of life's history. The vast majority of species that have ever lived are now extinct. Understanding the causes of past extinctions, whether they were gradual or sudden, can provide insights into the vulnerabilities of life. These lessons are particularly relevant today as human activities are rapidly changing the global environment. The Earth's history is a story of remarkable resilience. Life has endured through massive volcanic eruptions, ice ages, and asteroid impacts. It has found ways to persist and diversify even after catastrophic events. However, this resilience also highlights the fragility of individual species and ecosystems. The current rate of biodiversity loss, driven by human actions, is alarming. By studying the deep past, we can better appreciate the intricate web of life and the importance of preserving it for the future. The echoes of ancient extinctions serve as a stark warning. Ultimately, the study of pre-human life connects us to something larger than ourselves. It is a journey of discovery that reveals our deep evolutionary roots. We are the inheritors of a biological legacy that stretches back billions of years. We are the species that developed the capacity to look back, to question, to understand this immense history. This knowledge is a powerful tool. It allows us to appreciate the beauty and complexity of life. It encourages us to be responsible stewards of our planet. The story of who roamed Earth before us is in many ways our own story too.